Okay, in today's class, I will discuss about relation between electric field and the potential difference and also Maxwell's equation. We have already discussed about the potential difference. Potential difference. These are position vectors of A and this is position vector of B or B. And let us consider a small dl whose position vector is R. These are the paths from A to B and B to A. We already discussed about the potential difference between A and B. That is VAB is equal to minus integral E dot dl minus E dot dl. Integrating from RA to RB. That is the work done in moving a unit positive charge from A to B, where E is the electric field, that is the force experienced by unit positive charge, and dl is the small distance. Okay, if you integrate this, we will get the complete work done for in moving unit positive charge from A to B. From B to A, what is the potential difference between B to A is minus integral RB to RA E dot dl, which is equal to integral RA to RB E dot dl. I have just changed the limits. Here it is from RB to RA, it is RA to RB, so I have removed this minus sign. If I add these two potential differences, VBA plus VAB is equal to, we get 0, which can be written as the total work done, that is in the closed loop from A to B and B to A is shown by the circle. E dot dl is equal to 0. E dot dl is equal to 0. This is called as integral form of Maxwell's equation. Maxwell's equation. Integral form of Maxwell's equation. According to Stokes' theorem, line integral A dot dl, A is a vector and dl is also a vector, is equal to surface integral del cross A, this vector product is also called as curl, this curl dot ds is equal to 0. Applying this Stokes theorem to this integral, we will get E dot dl line integral is equal to del cross E dot ds surface integral is equal to 0. Okay, this del cross, if you consider this equation, del cross E dot ds integral of this is equal to 0, then del cross E will be equal to 0. This is called as differential form of Maxwell's equation. Okay, now let us see about the actual relation between E and V. Relation between E and V. What is the difference between A and B is integral RA to RB minus of integral RA to RB E dot dl, where E and dl are the vectors. This can be written like this. minus of integral E dot dl. E dot dl. Okay. Then delta V is equal to minus E dot dl. To differentiate both sides, we will get del V. And both sides, we will get dV is equal to minus E dot dl. We know that the vector E is equal to Ex Ax cap, where the Ax cap is unit vector, plus Ey into Ay cap plus Ez into Az cap, and dl is equal to dx into Ax cap plus dy into Ay cap plus dz into Az cap. This Ax cap, Ay cap and Az cap are the unit vectors in x, y and z directions. Now let's find out the dot product of these two equations now. Then dv is equal to Ex Ax cap plus Ey Ay cap plus Ez Az cap dot dx Ax cap plus dy Ay cap plus dz Az cap. Let us find out the dot product of these two expressions. Then dv is equal to this term is multiplied with all these terms. First term multiplied with first term, again second term, and then third term. So multiply these two terms now. Ex Ex cap dot dx Ax cap, which is equal to Ex dx Ax cap dot Ax cap. These two are vectors. So dot product of this is equal to Ex dx magnitude of Ax into magnitude of Ax into cos of the angle between these two is 0. Cos 0 is 1. So this is equal to Ex dx. Ex dx only. Ax cap. Magnitude of Ax cap is 1 unit and Ax cap is also 1 unit. Ax cap 1 into 1 is 1. So the final result is Ex into dx. Right? Ex into dx. Now multiply this with this, we'll get Ey that is Ey Ay cap dot Ex Ax cap, which is equal to Ey Ex into Ay cap dot Ax cap, which is equal to Ey Ex magnitude of Ay cap into magnitude of Ax cap into cos of the angle between them is 90. Cos 90 is 0. So this term will be equal to 0. This into this will be equal to 0. The same way, this into this also will be equal to 0. Now coming to this now, dy Ay cap into Ex Ax cap will be 0. Dy into Ey Ay cap dot Ay cap is 1. So you can write Ey dy plus Ez dz. So dv is equal to Ex dx plus Ey dy plus Ez dz. Okay. From the calculus of multivariables, dv is equal to dou by dou x into dv by dx del v by del x into dx plus del v by del y into dy plus del v by del z into dz. According to the calculus of multivariables, dv is equal to del v by del x into dx plus del v by del y into dy plus del v by del z into dz, which is equal to dv. Okay. So dV is equal to minus of E dot dl. So put minus here. So we'll get minus of this. If you compare these two now, we will get Ex is equal to minus del V by del X, and Ey is equal to minus del V by del Y, and Ez is equal to minus del V by del Z. Del V by del Z. Now let us find a relation between Ex and just between electric field and the potential difference V. Know that E is equal to Ex into Ax cap plus Ey into Ay cap plus Ez into Az cap. So E is equal to Ex is what? Ex is minus del V by del X. So minus del V by del X into Ax cap minus del V by del Y into Ay cap minus del V by del Z into Az cap. So E is equal to, this is a vector, E is equal to, this can be written as minus del V, where del is nothing but del by del X into Ax cap plus del by del Z into Ay cap plus del by del Y dy cap del by del Z into Az cap. So this is called as gradient of V. Gradient of V. So finally we got the relation between E and V, where this vector E is equal to minus del V. That is the relation. Okay, it depends on the coordinate systems. It can be rectangular coordinate system, it can be cylindrical coordinate system, or it can be spherical coordinate system. Okay, just we have derived for rectangular coordinate system. Now we'll see about the spherical now or cylindrical. So E is equal to, for, let us see, for again for rectangular coordinate system, this is equal to minus del V by del X Ax cap minus del V by del Z into Az cap minus del V by minus del V by del Y into Ay cap minus del V by del Z into Az cap. E is equal to, okay, this is for rectangular coordinate system. Now for cylindrical coordinate system, cylindrical coordinate system, the variables are rho, phi and z. These are the variables, where rho is the radius of the cylinder and phi is the angle between x axis and the radius, and z is the height of the cylinder. Okay, according to these cylindrical coordinates, this E is equal to minus del V by, with respect to rho, it is rho into d rho a rho cap plus dV by rho into d phi a phi cap plus rho v by dz del z into az cap. Okay, this is the relation between electric field and the potential difference. That is E is equal to del V. E is equal to del V. For spherical coordinate systems, the variables are for spherical r, theta and phi, where r is the radius of the sphere and theta is the angle between radius and the z-axis and phi is the angle between x-axis and the radius of the cylinder, that is rho. So here E is equal to minus del V by r into dr ar cap plus del V by, for theta it is r into is only dr here, dv by dr into ar cap plus dv by r into d theta a theta cap plus del v by r sin theta into d phi a phi cap. This is the relation between A and del V. We have considered all the three coordinate systems. This is according to the rectangular coordinate system and this one is according to the cylinder coordinate system. This one is used for according to the spherical coordinate system. We will do one numerical to understand the concept well. Okay, just now have derived the relation between electric field intensity and voltage potential, that is E is equal to minus del V, which is also called as gradient of voltage potential. We will do some numericals on this. E is equal to minus del V. Given a potential V is equal to 10 by r square sin theta cos phi. Find the electric flux density D at this point 2 comma 5 by 2 comma 0. These are in spherical coordinates. These are spherical coordinates and the expression is also given in spherical coordinates. And the second bit is calculate the work done in moving a 10 microcoulombs charge from point A to point B. A coordinates are 130 degrees and 1 comma 30 degrees and 120 degrees, and B coordinates are 4 comma 90 degrees comma 60 degrees. Okay, let us do now the first bit. Find the electric flux density D at the given point 2 comma 90, that is 5 by 2 comma 0. You know that this electric flux density D is equal to epsilon naught E, where this D and E are vectors. This one we have already derived in the earlier classes, and E is equal to minus del V. Okay. First we will find out electric field and then find out the flux density. The electric field is a vector. E is equal to minus, what is del in spherical coordinates? In spherical coordinates it is dou by spherical coordinates are r, theta and phi. Okay, the differential length, that is dr, dv by dr ar cap plus dv by theta is r d theta, that is differential length r d theta into a theta cap. A theta cap is unit vector plus dv by r sin theta d phi a phi cap. Here a phi cap. A phi cap is a vector. Okay, we will use this expression now for finding del V. Okay, we will consider term by term and then add all the terms. Let us find out dV by dr of the given expression V is equal to 10 by r square sin theta cos phi. So 10 by r square here with respect to dr we are differentiating. So the constants are r and phi. Constants are sin theta and cos phi, and we are differentiating with respect to r. So it is 10 by r square. I am taking common, not 10 by, not r square, 10 into sin theta cos phi. These are the constant, and we are differentiating with respect to r. So it is d by dr of r power minus 2, which is equal to 10 sin theta cos phi. D by dr of r power minus 2 is minus 2 into r power minus 3. Already this r, so this is equal to minus 20 sin theta cos phi by r cube into ar cap, which is equal to minus 20 by, now let us substitute the coordinates, cylindrical coordinates. R is 2 and theta is 5 by 2 and phi is 0. Let us substitute those now. R cube is 2 cube. 2 cube is 2 cube 16. 2 into 2 into 2. 8. 20 by 8 into sine theta is 90. Sine 90 is 1 by 2 and cos 0 is 1. So which is equal to minus 20 by 8 AR cap. Minus 20 by 8 AR cap. And coming to this term now, dV by r d theta into a theta cap. Here AR cap is there, a theta cap, which is equal to 1 by r. What is V? V is 10 by d by d theta of V is 10 by r square is constant, cos phi is constant, and we differentiate this sin theta. Okay. We'll take out the constant. 1 by r into r square is r cube, 10 by r cube into cos phi to d by d theta of sin theta, which is equal to, the derivative of sin theta is cos theta, which is equal to 10 by r cube cos phi cos theta. Now let us substitute the values now. What are those? 2, 5 by 2 and 0. Substitute 2, it will be 8, and cos phi, cos 0 is 1, 10 by 8, cos 0 is 1, and cos 90 is 0. So this term will become 0. So the second term will be equal to 0. And the first term is minus 20 by 8. This one is minus 20 by 8 AR cap plus this is A theta cap plus, let us do the for the third term also. Second term is 0. That is minus 20 by 8 AR cap. Third term is dv by r sine theta d phi. With respect to phi, I have to differentiate. It is equal to 1 by r sine theta is constant and d by d phi of v is what? 10 by r square sine theta cos phi. I will take out the constants outside now. 1 by r, this r square is r cube, this sine theta, 10 also taking out, 10 by r square sine theta d by d phi of cos phi, which is equal to sine theta will be cancelled, 10 by r cube into derivative of cos phi is minus sine phi. Let us substitute the coordinates now. R is 2, so it is 10 by 8 minus sine phi. Phi is 0, sine 0 is 0. So it will be 0. So third term is also 0. Second and third terms are zeros. So finally this E is equal to minus of minus will become plus 20 by 8 AR cap coulombs per meter square. Okay, so which is equal to 2.5. 5 by 2 is 2.5. 2.5 AR cap coulombs per meter square. But what is D? D is equal to epsilon naught E, which is equal to 9 into 10 to the power of 9 into E is 2.5 AR cap coulombs per meter square, which is equal to 22.1 into AR cap picocoulombs per meter square. That is the value of D. Now let us do the second bit now. Second bit. You know that the potential difference between 2 points VAB is equal to VB minus VA. I already derived this V minus VA. Potential difference between 2 points is defined as the work done in moving a unit charge from point A to point B. Now we need to find out the work done in moving a 10 microcoulomb charge from point A to point B. But VAB is nothing but work done in moving 1 coulomb, 1 unit charge. Okay. So for moving Q coulombs, work done in moving Q coulombs from A to B is Q into VAB, which is equal to Q into VB minus VA. That is for moving from A to B, point A to point B, the Q coulombs of charge from point A to point B is nothing but Q into VBA, joules. Q is given as 10 microcoulombs. Q is 10 microcoulombs. So W is equal to 10 microcoulombs into VB minus VA. So for VB, we have to consider this coordinates at B and find out VB. From the given expression, we know that given expression is V is equal to 10 by R square sin theta cos phi. So VB is equal to VB. You have to substitute these cylindrical, spherical coordinates that is 4, R is equal to 4, 10 by 16 sine theta 90 and cos 60 which is equal to 5 by 4, 5 by, let us leave it like that, 10 by 16, 4 square 16, sin 90 is 1, cos 60 is sin 30, sin 30 1 by 2, cos 60 is 1 by 2. So this is equal to 5 by 16. B, right. Which is equal to 5 by 16. So VB is equal to 5 by 16. In the same way, let us find out VA now. VA is equal to 10 by R is 1 square sin 30. Sin 30 is 1 by 2. Cos 60 is minus cos 60. Cos 120 is cos 180 minus 60. So which is equal to 5 to minus cos 60. Minus cos 60. Cos 60 is 1 by 2. So it is minus 5 by 2. Minus 5 by 2. Minus 5 by 2. So VAB is equal to, or work done is equal to, Q is 10 into VB is what? 5 by 16 minus of minus VA minus 5 by 2, which is equal to, it will become plus. Finally, because 10 microcoulombs, 10 to the power minus 6 is there, 10 to the power minus 6, which is equal to, 125 microjoules. Joules is the unit of work. Microjoule, this is the answer. Okay, with this, the numericals on the relation between electric field intensity and voltage potential is over.